Towery, Ag Conservation Solutions, crop consulting company, kind of specialize in no-till cover crops, and now soil health. So just so I know a little bit about you folks. Anybody here no-till soybeans? Okay. Corn? Okay. Cover crops? Okay, very good. What kind of cover crops you use?
Annual rye.
Annual rye?
Cereal.
Cereal?
Radish oats.
Radish oats?
Radish.
Okay. Okay. Good part of what we're going to talk about with soil health is, A, get a little bit better understanding of what in the heck what are we talking about with soil health?
Nutrition.
Nutrition, okay, it's part of it. What else is soil health? What are you expecting?
Tilth.
Huh?
Tilth.
Tilth, okay, okay. There's lots of different ways to. Bottom line is, I mean, right out here we've got some of the most productive soils in the world. But the question is, are they functioning at as high of a level as they can? And I'll just take one to get started. One example. Just had a big storm here. Well, part of a healthy soil is the soil is in a state so that a heavy rain with limits is going to go into the soil instead of running off. So, it's something that's very gradual, but, and there's limits, but that's the type of thing that we're going to talk about. So, I'm originally from Illinois. Actually, let's see, I moved to Indiana about 17 years ago. And, I'm originally from Havana, but don't hold that against me, okay? I don't tell that to everybody. But I got to say that from a state financial standpoint, I made a pretty good move. They're talking $2 billion surplus over in Indiana right now. So anyway, oh yeah, soil health, that's what we're talking about. So, signs of a great soil, signs of a healthy soil. It's black. All the soils around here pretty well are black, but it's the finer points, the nice granular structure that was just pulled out of the field, not altered in any way, shape, or form, and it smells good. It's got the structure that, yes, you just look at it and you know that is good. So, 2012, this is from Indiana, and this is just one example of going towards a healthy soil, what it can do. Fields side by side, planted the same day. They were not the same variety, however, so be upfront with that. But this was conventional tillage, no cover crop, ended up going 65 bushel. I think this photo was taken in mid-June. Over here, this was no-till planted into a cereal rye cover crop. Did 109. Still got hurt, but not nearly, still looking at a 40 bushel or so difference. Can we expect that every year? Absolutely not. But that's one of the things with a healthier soil, it's a more resilient soil. So should be able to take weather extremes, whether it be too much rain or not enough rain. It can do a better job handling that. Microbes. Got any microbes? Always, yes. These are some of the different ones that are in the soil. But, if I had a handful of soil, how many microbes would be in that soil?
Be a lot of them.
A lot. One number that I saw, and I know that they didn't count the damn things, but it was like 6 billion. Same as what the population of the earth in one handful. Well, those are numbers I can't relate to. I would say it was the numbers I can relate to is what the balance in my checking account or the mortgage on my house. 6 billion is just, can't get your arms around it. So I'm going to give you a little bit different way to hopefully that you can relate a little bit more. It's the microbes in the body. They're invisible, can't see them, but they're everywhere. We would not be able to exist without microbes, and they rule. Microbes in your body can weigh as much or more than your brain. Now, the two groups this morning, we had a few that I'm not sure they would need all that many microbes to weigh more than the brain. It was, brain may have been a little bit light, but they outnumber your own cells 10 to 1. But yet, with all of modern medicine, there is still so much that we don't know about the microbes in the body. And we take this to the soil and it's exponentially higher. So let's just take the bacteria in your gut. Everybody just ate. That bacteria in your gut is helping you digest that food. It absorbs nutrients. It protects the intestinal walls. It helps regulate weight. It wards off autoimmune diseases. And most of the bacteria are either beneficial or unobtrusive freeloaders. Everybody relate to what an unobtrusive freeloader is? So, do what? Yeah. So, or it could be an obtrusive freeloader. So, but yet we take it for granted. We don't understand it. And even if you have a disorder, and the doctor needs to prescribe an antibiotic, let's try this one. Because we can have side effects. It disrupts the bacteria in the gut. It can cause things like diarrhea. And all you can do is put that in your medical file and stay away from that one. I don't get along well with it. So anyway, a lot of work going on now. And it's not looking at the individual microbes, but it's looking at it as a collection. And it's a very dynamic environment. The numbers are constantly changing, constantly in flux. So, types of microbes in the soil, you got bacteria, algae, fungi, mycorrhizae, nematodes, macroarthropods, microarthropods, earthworms, protozoa. Only ones that you can really see are the earthworms. I call them soil critters. Just make it real simple, soil critters. One that I do want to talk about, this is a root hair, okay? When you plant a cover crop, and again, think about it. We've got corn or soybean growing for what? 5 months max? Okay. Well, that corn or soybean plant is growing. It's all about taking the sunshine, using photosynthesis, and turning it into carbon, corn or soybean grain. But yet, I mean, corn is done after it reaches black layer, and soybeans a little bit later, as long as it's got any green leaves. So you have a fallow period. Then in the spring, there's a fallow period until you plant the corn or soybean and get it going. We're wasting sunshine. that we could put to a good use. That's called putting carbon back into the soil. So the cover crops release an exudate. Basically, it leaks sugars. So there's a symbiotic relationship between the mycorrhizae fungi and the cover crop plant. The plant leaks these sugars. The hyphae uses them. They produce a hyphae. That's what these are here, is hyphae coming off of the root hairs. The hyphae bring additional water and nutrients to the plant. I saw one study that corn roots, on average, come in contact with 3% of the soil. Have a highly biologically active with a lot of these mycorrhizae fungi, the hyphae. They can come in contact with 20% of the soil. Additional water and nutrients to the corn or soybean plant. Again, in those extreme years, makes a big difference. So again, more of the pictures of the soil critters. I'm not going to dwell on those. But I do want to talk a little bit about the importance of the soil microbes, because you realize all the fertilizer that you put on, that's to increase certain of those microbes. And then when they die, they give off carbon and nitrogen. So the bacteria has a 5-to-1, fungi a 10-to-1 carbon to nitrogen ratio. Bacteria can reproduce in 30 minutes. Nematodes takes 2 years. Fungi, we're not really sure. So, but the thing that we do know, the microbes are more likely to be located big time close to the roots. This is part of the evolutionary process that's happened for hundreds of thousands of years. Okay, so the mycorrhizae fungi is the one that I want to talk about a little bit more. As I said, it acts as an extension of the plant roots. But mycorrhizae, it takes time for their numbers to increase. The fungi produce a product called glomalin. It's like a glue. Okay, that is what improves the soil aggregation. It improves the pore space. Corn and soybean plants, the roots need oxygen. You got to have pore space so you can get that air exchange occurring. One of the ingredients for high yields. But the improved soil aggregation, intense rainfall, you're going to get the water going into the soil. So our land-grant universities have done a pretty good job on the physical and chemical soil properties, but the third leg of that stool is the biological component. That is one that we're just scratching the surface on, really, and understanding. It's very complex, and we're going to look at some soil tests here in a minute. But the bottom line is more biological activity, keep something growing as much as possible. Granted, when the ground's frozen, you're not going to have anything happening, but try to have something growing in that fall and spring. It's a dynamic system. It changes over time, primarily due to the changes in soil biology. So how do we get more active soil biology? We manage it. We make that a priority among 20 other priorities that you have in crop production. But it's about the numbers and the diversity of the microbes. You know, the microbes are kind of like organic matter. It's only going to go so low, it's only going to go so high. Nature has a way of keeping things from getting too far out of the norm. So I'm going to use, this is Dan's scale, 1 to 100. It's just to give you a little bit of a reference point. So, poor soil structure, biological rating of 10. You know we got crusting issues. It's hard to get a good stand. We don't have that air exchange that's needed. So, you got four principles. Minimal soil disturbance. So, and it's a relative term, so take it for what it's worth, but minimal soil disturbance. We want to keep the soil covered. In this case, it's residue. That's going to do, one, it's going to stop the erosion. Secondly, it's going to slow down the evaporation. It's also going to make cooler soil temperatures. In 2012, we did some measurements of soil with cover and without cover. We saw about a 25-degree difference in temperature. It got up to 112 at the 2-inch depth where we didn't have any cover. A diverse crop rotation and/or cover crops. We're not going to see major changes in our crop rotation. I mean, it's corn, beans, maybe a little bit of wheat for some of you, but whether it's continuous corn or whatever. However, with the cover crops, we can put a little bit more of a diverse crop rotation effect out there. These are the holes. So what was planted in here? Radishes. And this one down here is annual ryegrass. So again, we add variety to it. So again, the idea, keep something growing every day possible. Have a living root in the soil as much as possible. That's basically taking care of that fallow period with the cover crop. So again, we want to take that sunlight, we want to produce carbon at a time when normally nothing is happening. You know, in the Great Plains, we get out where moisture is limited, and they had typical rotation was what? Wheat fallow. And the fallow, they'd either spray Roundup to kill it, to control the weeds so they wouldn't take up moisture, or you'd till it about 3 or 4 times. Well, growers out there figured out that they could put, instead of wheat fallow, crop it maybe 4 out of 5 years, switch to crops like sorghum, sunflowers, have it more of a diverse crop rotation, added cover crops to it, and their profit margin increased substantially. So a little bit different out here because we've got the moisture most of the time, but it's putting that carbon back in the soil. Who had cover crops last year? You did? What kind of growth did you get in the fall?
Wasn't that great.
Right. What about you?
No, it wasn't good.
Yeah.
On my soybeans, early planted soybeans, my oats and radishes were great, but early frost got them.
Okay. 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 Yeah. Last year was probably we saw the least amount of fall growth ever. One, it was the crops harvested late. Then it was fairly dry if we planted them late September, October, and then it turned cooler than normal. I mean, cover crops aren't any different than corn or soybeans. You know, they need sunlight, they need warm temperatures, they need nitrogen, some of them. I mean, those are just inherent factors to get good, robust growth. So, we drive by and I looked at a field of annual ryegrass and we slowed down to 45 miles per hour and not worth stopping. Well, I said, let's stop anyway and let's go out and dig. So this was the week before Thanksgiving last year. Ryegrass was about 2 inches tall. The roots were going down 21 inches. So we were getting more benefit than what we assumed, but still not like normal. But it's important to get out and do the digging, if you will, to see what's going on underground. There are 4 phases of soil health improvement. You go from one stage to the next. Initialization, it may be 4 years, 5 years in this phase. You may need additional nitrogen for the corn. So, we go to a biological rating of 30. The next phase is the transition. We start increasing the organic matter. Okay? Soil aggregation improves. We start getting an accumulation of phosphorus, and we start seeing nitrogen both being immobilized and mineralized. Soil biological activity improves. Then the consolidation, the carbon accumulates, and additional water is available. Again, extreme year can make a huge difference. Nitrogen is both mineralized and immobilized. We see an increase in the CEC and in nutrient cycling. When I was in college, I was taught that you can't increase the organic matter or the CEC. Well, you can, although it's not easy. So I give this a rating of 75. And then phase 4, and this may be 15 years down the road, you get into a maintenance. Carbon and nitrogen are flowing back and forth. Greater availability of water. Big improvement in nutrient cycling. Still going to need nitrogen and phosphorus, but you may be able to raise high yields with less by taking advantage of the soil biology. So these ratings were ones that Dan just plucked out of the air for comparison. So we're going to shift a little bit. I need some help. Anybody would like to help me? Don't jump all at once. Come on up. Anybody have any experience doing the Solvita test? Okay, it's relatively new. So what we did is got 100 grams of soil. These were taken yesterday, a little over 24 hours ago. And then there was a kind of a litmus type paper, special product put in that changes color based on the amount of carbon dioxide that is released. Okay, so we've got 3 samples. One is a corn and soybean no-till. One is corn on corn that was had tillage done every year, and then from a grass buffer strip. So we can use the color chart to see what the level is, or they provide a nice handy dandy electronic meter so that you can read it. Let's look at the grass one first. Okay, go ahead and pull that out of there.
This thing?
Yep. Oh, go ahead and leave the soil back in. Okay, so it has 2 sides, one for fluorescent light and the other for incandescent. We're kind of in between here, but let's see what do you think?
5.
5. 5 represents high level of biological activity. It's in a grass, whoop, no, we're not done yet. It's in a grassy area, so we would not disturb, so we think that would have it. So we think it was a 5. So we're going to use the electronic meter now. And it's got a little slot that we just push this in. This takes a few seconds. What does it read?
4.68.
Can you write that down for me?
Pardon?
4.68. Okay, that was the all grass. So high level of biological activity. So now we're going to do the corn on corn. Do you expect it to be higher or lower biological activity? Okay, so what do you think? Whoop.
Nope. Almost screwed it up.
It's hard to find good help.
Get what you pay for.
Yeah.
I'll say 4.
Okay, 4. All right, let's. Okay, go ahead and slide her in there. Okay, yep, then hit read. He could be a scientist.
4.63.
Okay. Now, this was corn on corn. So remember, this was side dressed, which caused some soil disturbance, put some oxygen in there, and would cause some oxidation to occur. You also had whatever influence that the nitrogen being applied may have on the soil microbes. Okay, so now we'll look at the no-till corn or soybeans. But this sample was pulled from soybeans, so we're not comparing apples to apples. Also, it was a wetter area of the field.
I'll go 3.5.
3.5. Okay. Okay. He's a quick learner.
4.48.
Okay. So a little bit less. So what were the numbers then?
468, 463, 4.4.
Okay. So the idea, if you send the sample into the lab, or from these numbers, from their software, they would be able to give you an idea of what kind of nitrogen and phosphorus that you could expect from the soil biology. So a little bit, just putting the side dress operation, it may have inflated it. So we're still learning how to interpret this thing correctly. But it's a tool that I think we're going to be using. Chris, thank you very much. What a great assistant. So again, this is just one of the new tests that I think that we'll be looking at as we go forward. So again, this is the graph, just basic. This is the increasing in carbon, and that it causes a whole cascade of effects. The aggregation improves, the infiltration improves, water nutrient holding capacity improves, and the productivity, especially in years where less than ideal weather conditions, those extreme weather events. So we talked about organic matter. Let's take a look at where the organic matter is coming from. Native prairie, that's what we had here, right? Tall grass prairie, 6 feet tall. Every 1 to 4 years, probably a fire came through, because if the fire didn't, it would have had trees there. But it's the roots, up to 30,000 pounds per acre. Very deep, they go 10 feet down, but most of them are close to the surface. So that's our nice black soils where they came from. So remnants of that prairie, the carbon, are still out there. So organic matter actually has 2 factions. One is the passive. That's been there for hundreds of years. It will be there for hundreds of years unless it's whooshed from the field with soil erosion. The active component is what we're interested in, because it's the freshly decomposed residue, roots, that type of thing. It's what gives us the increase in the biological activity. You can see annual ryegrass, cereal rye, red clover, oats a little bit less, corn we bumped back up to 3,000 to 4,000. Soybeans, 500 to 1,000 pounds. Soybeans are a net carbon deficit. In our corn bean rotation, we come up ahead if we don't stir the soil too much, but it's a very slow process. Whereas if we add the root mass from these cover crops, we can increase it quite a bit more. Okay, the earthworms, everybody kind of knows about that, but we actually have guys with a highly biological soil, you know, producing good yields, 200, 230, and you think, oh, the residue is going to be accumulating. Well, actually with an active soil biology, between the earthworms, they are many times complaining, I don't have any residue left on the soil in the middle of June. So this is kind of what I was talking about before, the change in the soil structure. Water can get through, the air can get through, get oxygen down to the roots, as compared to intense rain, it seals off. No more air exchange, oxygen exchange, and this water is running off. Shift gears a little bit to the nutrient management. You know, one tillage pass can release 40 pounds of N. Okay, so we're changing the balance when we stop doing tillage. So it's all about the nitrogen, the phosphorus, the carbon, and the sulfur. How many here are actually adding sulfur to the fertilizer? Okay, yeah, we've basically, because we've cleaned up the power plants. We put scrubbers to reduce the carbon dioxide. And of course now, anybody here using gypsum? Okay, and it's fairly popular over in Indiana. So, but it's a byproduct from the scrubbers, hauling it back to the farm to help chemically with the soil aggregation, and also a good source of sulfur. So early years of no-till, you may need slightly more in, especially up front. Don't need a lot, but definitely needs starter to compensate for no tillage, and then adding the sulfur. Sulfur is also an important ingredient in building organic matter. So we know that carbon, the nitrogen are important, but sulfur is also. And again, take-home message. If you're planting corn, the microbes eat first, corn plant eats second. So if you've got residue that needs to be decayed, the microbes are going to use that nitrogen to break that down. So there's some numbers for 1% organic matter. This is total, it's not necessarily available. 4%, it goes up big time, but this is what's important. 2% are typically only about 2% of those nutrients are available. So in a 1% organic matter soil, you've got 22 pounds of N. 4%, 88 pounds. That's what the Sylvita test is designed to do, to help looking at that soil biology and giving you an idea of how much nitrogen can come from the soil biology. So, and 2% is the traditional textbook. I think if we have a really active organic portion, that could be closer to 3%. So at 3%, changing that 2 to 3 at a 4%, we're talking potential of 132 pounds of N. Okay, that's kind of textbook, but what's important is what do you get on your field? and it may vary from one part of the field to the other. Carbon nitrogen management with the cover crops. The early kill date is most effective. We have less of a chance of tying up that nitrogen. So it can decompose quickly and release those nutrients that were captured or stored. Later kill date, we get more cellulose, more carbon, and the nutrient tie-up can use the available nitrogen. Here's one of the things people talk, is it crazy to no-till corn into cereal rye? Is that bad? No? It can be done? Okay.
Better kill that rye.
Better kill the rye. Okay, a couple of things going on. One, the cereal rye, as it matures, the carbon-nitrogen ratio goes from 14 to 1, potentially all the way up to 72 to 1. Okay, 25 to 1 is kind of the break point. Anything above 25 to 1, it is probably going to be the following year before that nitrogen is going to be available. Less than 25 to 1, it should be available for that corn crop. So one of the, cereal rye, don't let it get too big and burn it down when it's somewhere between 6 to 10 inches tall. The other issue, letting it grow bigger, is in a dry year, it can suck the moisture. So it's just, everything is always a juggling act. But even if we get up, 36 to 1, plant soybeans into it. Any issue planting soybeans into tall cereal rye? Who here uses cereal rye?
We have.
Okay, any issue planting soybeans into it?
No, we killed it, planted right into it this spring.
Okay, so did you kill it first or plant into it?
Killed it first.
Killed it first. And last year, again with our wet spring, to give you two examples of just where management can come in. Throw pollen, so it was tall. We talked about it. He decided to go in and plant into it green, which it's actually, take up the residue managers, it's actually easier to plant into a green cover crop than one that's been burnt down. There are other potential issues planting into something green, armyworm, that type of thing. Anyway, he and we know that it was shedding pollen because he had to stop several times to clean his radiator off. Soybeans went 65 bushel. I had some other folks that called me after the fact. They wanted to take the cereal rye off for forage. Great idea, but not the year to plant the entire farm to cereal rye. And then they were going to plant soybeans into it. It was wet, couldn't get in there. Finally, towards the end of June, they got in with the burn down. Well, by that time, cereal rye was yay big, and it was about a 4-inch thick mat that would not dry out to get the beans planted. They ended up burning part of that residue off. So, that's just, again, part of it would say it's guy got lucky, but it was understanding the system and what the options were available. But the carbon nitrogen ratio didn't make any difference at all with the, in fact, that nitrogen that was tied up in that tall cereal rye will be coming around the following year when corn is planted. Annual ryegrass, about 20 to 1. This is why guys like it, planting corn into it. We don't have as much biomass because typically it's going to be 6 to 10 inches tall at burn down, although we can talk about the burn down afterwards, but it is a little ornery in cold weather. But at this carbon nitrogen ratio, that nitrogen is available early July, right when the corn plant needs the most in. So that gives it, it's like spoon feeding the nitrogen to it. And you can see the legumes, again, no problem there. Corn stalks, 57 to 1. That's why we need more nitrogen, corn after corn. Microbes are eating first. And for grins, I put down sawdust at 250 to 1. So, threw this in, just a comparison. Where is the nitrogen? Everybody thinks that the nodules is where the nitrogen is. It's in the leaves. And you can see the numbers here in the tops versus the roots. Alfalfa is probably the closest to being 50-50. You know, I started my career in northwestern Illinois, in Henry County. Anybody here from Henry County? Okay. But it was in the early days of no-till. So it was no-tilling corn into alfalfa that had played out. Old Allis-Chalmers planter, 2-inch wide coulters. It's a wonder we ever had success. But even from back then, what we learned was if we burnt down the alfalfa in the fall, so it had time to decompose, guaranteed, as long as you got a good stand, it'd be the highest yielding corn on the farm. Because it's that 4 years of alfalfa, what it helped do to the soil biology. Okay, you see a lot of numbers. We got anybody selling cover crop seed here? Okay, I'll be gentle. We'll see different numbers. Hairy vetch, 140 pounds. Crimson clover, 115 pounds. Austrian winter pea, 144 pounds. All absolutely true. But we need to put a few caveats onto that. A little more explanation. That is what the potential is. Okay? So, this is, again, just from different studies that I saw, the total biomass, which can vary a lot. And, you know, annual ryegrass, cereal rye, the radish, these are all nitrogen scavengers. There has to be nitrogen in the soil profile for it to take up. I've seen a few times where you could tell in the fall there wasn't enough nitrogen for those covers. But the range, you know, what I've seen from 12 to 200 pounds. And again, how long is the cover crop growing? What kind of conditions do you have? There's all kinds of different variables. And then we have to pay attention to how much of that is actually going to be available. So, here's the big radish. Anybody grow a state fair radish last year? Yeah. How'd you do it? When did you plant it?
Labor Day.
Labor Day?
Drill and oats.
Drill and oats. Okay. Any nitrogen, any manure? Okay. And you got this kind of a, yeah, that's very good.
The corn got 3 feet tall this spring. You could really tell. I planted half a field like that, and you could tell a considerable difference when I planted the corn this year. It was 3 feet tall, actually was.
Okay, so
The branches and the oats was different color, dark green color, more vigorous growth.
Okay.
Couldn't tell the difference until it got that big.
yeah, okay. Everybody hear that? Basically where he had split the field, planted radishes and oats, crop looked much better behind the cover crop. These are, I mean, typically after wheat, you don't want plant radishes until early August. Put down 6,000 to 8,000 gallons of hog manure, so you've got plenty of nitrogen. May want to use a planter because the biggest competition radishes has is with each other. Always plant oats with the radish because with the radish it winter kills and there will be nothing left out there at all in the spring except loose friable soil. So actually the ones that are about 1.5 inch diameter, to me, that's the preferred. But this one, 250 pounds of N. Well, from the tuber and from the vegetation, yeah. But I don't think there's 250 pounds in this radish that was planted in October. Not sure. Didn't want to waste the money sending it to the lab, but there's no way. So we got immobilization and mineralization. You know, this is going on all the time. Again, this is what I talked about early spring. The 25-to-1 roughly is the break point of is it going to be available or not. Timing of application. Okay, this is the curve where corn takes up the N. So typically July, early July, takes up the most N. Okay. So, you know, no cover crop. All it is the more time that nitrogen, especially if it isn't stabilized, is in the soil, we get big rain events, has the potential of being lost. So the bulk of the nitrogen going on in side dress, most efficient. Cover crops, we take up some in the fall, some in the spring. Then depending on what cover crop it is, what the carbon nitrogen ratio, whether that's available here, you know, or sometime here. It's all about efficiency. So we've got guys with a highly biologically active soil are down to, they are putting on 140, 150 units and raising 200, 225 bushel corn. But they've been at it for a number of years, slowly improving the soil biology. Okay. Cost, seed you can get by pretty cheap for seed. You know, $27 to $45 an acre, depending on what you want to do. So, continuous no-till and cover crops, we can get that 0.2 of an increase per year in the top 6 inches. That's what I measured fairly consistently.
Is that in what type? You know, I'm starting this no-till cover crop venture last year.
Mm-hmm.
My organic matter start with 3.6, 3.7%.
Right.
Am I going to see as large that 0.2% a year, or is it going to be slower since I'm at a higher organic matter?
It will probably be slower since you're at that high. But remember, what we're really talking about is the active organic matter component and the passive. The passive has been there for hundreds of years. It's the active is what we're really more interested in. In fact, the paper just came out with kind of, when you sample for organic matter, if you've got any residue roots mixed in there with it, and that's included in the sample, they did a study and they showed that that could inflate the actual organic matter by 13 to 20%. So that's just an error in sampling. So, but we know that it's only going to get so high.
Can I get to 4%?
Oh yeah, yeah. But it's only going to go so high, but it's that active portion that you can we really see a change, because that's going to change the nitrogen mineralization rate, the moisture holding capacity. You're going to have a better environment for healthy roots. So again, better yields, especially in years with extreme weather events. Potential, less fertilizer inputs, but again, the guys that are doing this have been doing it for quite a while. It doesn't happen overnight, and then very gradually you want to put out nitrogen strip trials to really be very careful about putting on less. less ponding taking place and less loss of nutrients and improved cycling. I'll skip over that one. So anyway, this is kind of what we're talking about is the dynamics of the carbon-nitrogen ratio. It's all about management. It takes time to get your biology cranking, but it's having a plan to get there. And there will certainly be challenges that will need to be overcame. So, any questions or comments? Yeah.
So, you kind of showed some of these pictures of the hard crusting, that nature. You're under the opinion that a lot of guys in our area had a big, huge rain, you know, got dumped on, crusted over, rotary hoed it, still didn't work, and they've had these problems for multiple years. Are you saying that a cover crop mix would help stop crusting?
It would reverse the trend. It's not going to happen overnight. In fact, one of the things, it's kind of counterintuitive because I said, oh, guys that are using cover crops, by and large, have been the guys doing no-till, except for the radishes and oats and that type of thing. But planting a cover crop first, just even oats, or oats and radishes, help get that aggregate stability improved. That maybe is the first step for a year or two. Then switch over to trying to eliminate or minimize any soil disturbance. So I think that's kind of a new approach that we really haven't pushed, and I think it makes a lot of sense to kind of go in that direction. Because otherwise, a lot of times if it's that crusted, it's kind of compacted, and trying to go in there and put that corn seed in that compacted ground, I mean, it's a tough environment, especially if it dries out a little bit. So I think improving that aggregate stability is step number one.
In your opinion, what's the best cover crop or cover crop mix overall as far as being good for the soil and the crops afterwards?
This is on tape now.
Can you? There is no good, perfect cover crop. It's all depends on what your objectives are, what your management ability is. Right now, we've got a number of guys that are trying, and the one guy did it last year. Basically, after wheat, too far north to double crop soybeans, so planted a 12-way cocktail mix. So, and these are summer cover crops, entirely different from any of them that we've been talking about. It was sun hemp, it was cowpea, pearl millet, basically with the idea of that diversity and for the growth that you can get in July, August, September, because many of these will first frost and they're toast. But with that growing time and with that diversity, it's kind of like taking the soil biology and giving it a steroid shot. So now, what we want to see though is how does that a corn, soybean, wheat rotation, how does the economics compare? And one of the things is, well, if we jumpstart the system with something like this, maybe you don't have to do it. It doesn't have to be part of the rotation every 3 years, maybe every 6 years, maybe every 9 years. We don't know. But we know that there's a lot of nitrogen that's going to be fixed, that's going to be available for that corn crop. And there's going to be, all I know is the planting conditions are just to die for. I mean, it's great conditions in planting corn into. So, it's every cover crop has its place. Annual ryegrass is great because it gives up the nitrogen. It's a little tough to kill when it's cold. You gotta have your A game to take care of the annual ryegrass. Cereal rye is a lot easier to kill. In wet weather, it can get away from you. But there's some management things. For example, if you're applying an ATV sprayer, so if it's wet, you can still get out there and spray. May not be a great option, but you can always have your brother do it. We've got guys doing it, so it's don't use it every year, but it's, you know, it's there if they need it. So, but more diversity is good, but at the same time, I mean, I've seen too many times like crimson clover being planted. In this area, it's going to be the last week in April that it gets to pre-bud stage. Well, in a normal spring, what's normal? In a normal spring, they'd be putting the burn down on like the second week of April. Well, it's fixing most of its nitrogen in April. So that 130 potential that you had with the crimson, it's probably back closer to 30, 40 by burning it down. So then you have to evaluate, do I want to include that in the mix or not?